Hello students, now we are going to start objective type question level 2 series for class 11th physics of the chapter unit and measurement. So now let's begin with the first question. Force F is equals to alpha by rho plus beta q. If rho is the density, the dimensions of alpha and beta are. So we have these options. Let's move with the solution part. So students, the like F is equals to given alpha divided by 14 questions. If the mass of the electron is 9 10 to the power minus 31 kg is taken as unit of mass. The radius of the first Bohr orbit 0.5 10 to the power minus 10 meter as unit of length and 500 Newton as the unit of force. Then the unit of a time in the new system would be 3 10 to the power minus 22 second, 15 10 to the power minus 12 second, 15 10 to the power minus 20 second, and 45 10 to the power minus 20 second. The correct answer for this question is, okay, let's see the solution first. F, force. The dimension formula for force is mLt minus 2. So after putting this value, we get the value of a t to the power minus 2, which comes 3 10 to the power minus 22 second. From here, like options, we can see the first option is completely matched with our answer. So the correct answer is the first option. Next question we have, if pressure P, velocity of a light c, acceleration due to gravity small g are taken as a fundamental physical quantities, then dimensional formula of mass is, we have these options. Now move with the solution part. P, pressure, ml minus 1 T minus 2. C, LT minus 1. G, LT minus 2. We just see the proportionality things in the dimensional form and comparing, get the value of A, B and C. We just put all these value here and finally get the value of M, which is P1 C4 G minus 3. Option 1 is the correct answer for that. Next question. The work done by a force in SI system is 30 joule. In a new system, if the unit of a mass is taken as 3 kg, unit of length as 4 meter, and unit of a time as 20 second, then what will be the next work done in a new second? We have these options. Let's move with the solution part. Now applying the dimensional analysis equation, which is a N1 U1 is equals to N2 U2. We just put the dimensions of a first system we can take as a MKS and second as a CGS system. Numbers in the MKS and numbers in the CGS system. Equating all these values and get the formula of N2, like get the value of N2, which is 250 Newton. So 30 joule is equals to 250 Newton are there because of 1 unit. So 30 by 250, according to that, 0.12 joule. Now, actually we calculated here 1 unit, but the answer is only asked like the value of M2. So this is a D option. The work done by a force in an SI system is 30 joule. In a new system, if the unit of mass is taken as 3 kg, unit of length as 4 meter, and unit of time as 20 seconds, then what will be the work done in joule in the new system? 0.12 joule, 250, 0.25 and 100. So let's move with the solution part. N1, M1, L1, 2, T1 minus 2 is equals to N2, M2, 1, L2, 2, and T2 minus 2. So put all these value here and get this value like earlier which we get 250 Newton. Now here the question is asked new system for the 1 unit. So this is a 0.12 joule which we did earlier, and the correct option for this is a 1. The volume of a sphere is 1.76 centimeter cube. The volume of 25 such spheres according to idea of a significant figure in centimeter cube. 44.00, 44.0. Yes, student, I am speaking like point 0 also because it is a significant number. 44, 4.4. Solution we have given the volume of a sphere is actually 4 by 3 pi r cube, which is a 1.76. So number of a sphere is a 25. So we just multiply 25 with this volume, and final answer which we get 44. So round off the minimum significant figure is as 1.76. So V is equals to 44.0. Why we have taken like 1.7 like 44.0? Because here the digit is a 3. So we have to take 3 up to like significant figure up to 3 digit. Next question. The velocity of light in vacuum is 30 crore meter per second. If it is expressed standard up to 3 significant figure, then which will be the correct? So given c is equals to 30 crore meter per second, so 30 10 to the power 7 meter per second, we write as a 30 10 to the power 8 meter per second, or we can write up to as a this will be 3 point, okay, 3.00 10 to the power 8 meter per second for a 3 significant figure, because we have to calculate 3 significant figures. So this is the correct answer for that. According to that, we have a third option is the right answer. Next, for question number 20, the percentage error in the measurement of mass and speed are 2% and 3% respectively. The maximum percentage error in the estimation of a kinetic energy of a body measuring its mass and speed will be 11%, 28, 11%, 8%, 5%, 1%. Now move with the solution part. Given delta m by m into 100 is equals to 2. Delta v by v into 100 is equals to 3. So kinetic energy is directly proportional to the half mv square. Half is a constant, which is a, I'm just sending with the like proportionality sign. So maximum percentage will comes 1 because the power is a 1. Delta m by m into 100 plus 2 delta v by v into 100 for the percentage. So 2 plus 2 into 3, which comes 8%. So this is the correct answer for that. Next question we have, a body of a mass 3.513 kg is moving along the x-axis with the speed of 5.00 meter per second. The magnitude of momentum is recorded as a, so we have these options. The solution is given mv, and the formula of momentum p is equals to mv. This is not a rho actually, student, this is a p. We just put all these value, and because the question at least number of a significant digit in the problem and the round of answer, so 17.6 kg per meter is the correct answer with the significant values. I hope you are understanding, students. Rho plus beta cube. From the principle of a homogeneity, we know that if the equation of LHS is equals to the equation of RHS by dimensionally correct way, then this is the following principle of homogeneity. So we know that the force dimension is mlt minus 2. So from here we can easily calculate the value of alpha and beta. For that, beta cube is equals to rho is equals to ml minus 3. So from here we can calculate the value of beta. Now from the beta, as you can see, we have only one option related to that, which is a third option, as you can see over there. So we can directly do mark on there. But for more confirmation, we just do more solution. So similarly, we just put this value of a beta and got the value of a alpha also. And alpha will be get ml2, ml minus 2, m2l minus 2, t minus 2. So this is the value of alpha, students. According to this, the correct answer which we have 3. Next question we have, if the unit of power is in million erg per minute, the unit of force is 1000 dyne, and the unit of time is 1 by 10 second. The unit of strength is 5 centimeter, 3 centimeter, 5 by 3 centimeter, 3 by 5 centimeter. So students, let us see the solution of this question. P is equals to 10 to the power 6 by 60 erg per second, where F is equals to 10 to the power 3 degree. So T is equals to 1 by 10 second. From here we can say that L is equals to PT by F. P is equals to W by T is equals to L F by T. And from here if we put all these values, so I get the value of T, which is a 5 by 3 centimeter. According to that, this is the value of a length actually, which is a capital L. So capital L is equals to 5 by 3 centimeter, which is option 3. Next question we have, in the above equation, unit of a mass is 6 gram, 12 gram, 3 gram or 24 gram. Same equation we will follow over there, like P is equals to ml to t minus 3 and m is equals to pl minus 2 t 3. So from here P is 10 to the power 6 by 60, L is equals to 5 by 3 and L is equals to 1 by 10. We just put all these value here and get the value of m, which is 6 gram. According to that, the first option is the right option. Next question, if the unit of mass is alpha kg, the unit of length is beta meters and the unit of time is gamma second, the magnitude of a calorie in the new system is, we have these options. Solution. So we know that energy is any kind of energy. The dimension formula is ml to t minus 2. Now the value of m, alpha, mass alpha is given, L, beta, so beta is square, gamma minus 2, this is in the joule. According to that, the correct option for this question is second one, because this is in a calorie and 1 calorie is given already in a 4.2 joule. Next question is, the parameters m q to the power 4 epsilon naught square h square has a dimension of m mass, q charge, epsilon naught permittivity and h Planck's constant. So the thing is showing for what? Wavelength, power, angular momentum or energy. So students, we know x is equals to, suppose this is a x which is equals to m q to the power 4 epsilon naught square h square. So what we are going to do, we just put the dimension formula of each and everything. And after solving, which dimension we receive, that is ml to t minus 2. And from the basics, we know this is a simply energy's dimensional formula. So for that, correct option for this question is fourth. Next question we have 8 pi epsilon naught k x by q square is the dimensionless quantity. Then dimension of x are where epsilon naught permittivity, k energy, q charge. Options we have are these ml to t minus 2, ml t minus 2, ml t minus 1, m0 l t0 and ml minus 1 t minus 1. Solution what we have, we just put this value in the dimension form and equating each and every value. M minus 1 L minus 3 T4 I2 x M1 L2 T minus 2 I2 T2. So this is equals to our dimensionless quantity which is M0 L0 T0. From here we got the value of x which is L. So from here we can say the third option is the right option. Next question which we have, if L is the inductance, C is the capacitance and R is the resistance, then R under root C by L has the dimensions ml t minus 2 I minus 2, ml to t2 I, ml minus 1 t minus 2 I minus 1, ml0 t0 I0. Solution we have R is actually R times under root C by L is equals to constant. So m1 L2 t minus 3 I minus 2 is with under root m minus 1 L minus 2 t4 I2 by m1 L2 t minus 2 I minus 2. So this is a m1 L2 t minus 3 I minus 2 into m minus 1 L minus 2 t3 I2. After putting all these values, we get the dimensionless quantity again. So accordingly, the fourth option is the right answer. Moving ahead with the next question. If solar constant is equals to 2 calorie per minute per centimeter square, its value in SI system is 1400 watt per meter square, 8.4 watt per meter square, 140 watt per meter square, 4.2 watt per meter square. Now let's see the solution of this question. So yes. So this is a 2 calorie per minute per centimeter square. We just put all these value over there and got this value 1400 watt per meter square. Students, in the solar constant, this is actually given here. This is equals to 2 calorie per minute per centimeter square. So what I did, just converted this meter into second, centimeter into meter, and calorie into joule. So we know that 1 calorie is equals to 4.2 joule. Similarly, I did with the same and get this value. I hope you understand like how I did the procedure part. Okay, accordingly, first option is the right answer. Next question we have, if the magnetic moment B is the magnetic induction, M is the what? Magnetic moment. B is magnetic induction and T is time. Then MBT2 has the dimensions of intensity of magnetization, intensity of a magnetic field, moment of inertia, magnetic permeability. Now let us see with the solution part. So MBT2, I'll just put all these value here. M, magnetic moment. That means mu r square, I, L square. So here M1T minus 2, I minus 1. This is a B and T2 simply we just put T2. So as last what we get ML2 which is the actually moment of inertia. Okay, so third option will be the correct answer. If mu is the permeability, B is the magnetic induction, R is the radius and I is the electric current, then Which of the following is dimensionless? From here, what we are going to do, I'll just check one by one. So for a systematic way, what we can do, we just put this value of a mu. So mu, like mu I by br, if I just put. So mu value we know, that is m l t minus 2 I minus 2, and simply I over there, so I. Now b m l t minus 2 I minus 1, and with the radius r, so again l. After solving, you can see there will be no dimension came, so the correct answer for this question is second. For this kind of a question, student, you have to, like, I'll just take it directly. So what you have to do, you have to take, just check down the one by one each and every term, and by practice you get the answer. There will be a little bit trick about that. Like, what we have to do, we just look the terms, like where the mostly terms can be easily deducted. Next question we have, if P represents radius of pressure, radiation pressure, C, speed of light, and Q, radiation energy, striking unit area per second, and x, y, z are non-zero integers, then p to the power x, q to the power y, c to the power z is a dimensionless. Then the value of x, y, and z are respectively. Students, we have these options. So now what we are going to do, solution part. We just put the value of a P, Q, and C. So P is actually given radiation pressure. So I'll just put the radiation pressure dimensions. Similarly, I did with the Q also, which is a radiation energy, and the last C, which is speed of a light. And any kind of a speed of a light or any kind of velocity, we have a dimension LT minus 1. Now, with this second part, we just do comparison, and after comparison, what result we receive, this receive like the value of p is what, actually a dimensionless quantity, which quantity this is equal, that is dimensionless, so m0 l0 t0 is equals to ml minus 1 t minus 2 to the power x, ml0 t minus 3 to the power y, lt minus 1 to the power 2. So comparing the powers m, l and t over here, and x plus y we get equals to 0. Next, x is equals to minus y we receive, and y is equals to minus x. So we have to calculate only single value, either x or either x or y. Okay. So from here, as we get the value of x is equals to z and x is equals to minus y also. So we just put this value in the equation, this, and get the value of like x, y, z. After solving, we get the value of 1 minus 1 and 1, which is option 2. Next question, which we have, a gas bubble formed from an explosion under water oscillates with a period t proportional to p to the power a, t to the power b, and e to the power c, where p is the pressure, d is the density of water, and e is the total energy of explosion. Then the value of a, b, and c are respectively 0, 1, 2, 1 to 1, 5 by 6, 1 by 2, 1 by 3, minus 5 by 6, 1 by 2, and 1 by 3. Solution, what we have, P, D, and E. We just put this dimensional formula in the final, like T is directly proportional to P to the power A, D to the power B. This is a P, and E to the power C. So one by one, I'll just going to put this particular formula and comparing all these terms, create an equation and get the value of a B. So B, we can other calculate the value of A also. So solving equation 1, 2 and the last one and get the result of a C which is a 1 by 3. So from the option we firstly check is the like C is the matching with our answer or not. We just tick over there also, but for more elaboration I just go with the A and C. So A is minus 1 by 2, B is minus 5 by 6. A is minus 5 by 6, B 1 by 2 and C 1 by 3. According to that, the correct option for this question is the fourth. Next question we have the reverberation period T of room depends on its volume V, its surface area A and velocity of sound C. If the K is dimensionless constant, T is equals to. We have these options. Now the solution part. V volume L3 is the dimension. A area L2 is the dimension. And C speed of light. So LT minus 1 is their dimension. Again for making the relation T is equals to KV to the power A to the power B and C to the power C. We just put all these value here and comparing start to power and 3a plus 2b plus 2 plus c is equals to made up of. So we just create different kind of equation. From here we can see c is equals to 1. We can put this value and get the value of a in the terms of a b also. And so a 1 by 2 and b minus 1 by 4 we receive and we have a c minus 1. So all these comparison what we say like if we put this value over there this is satisfied. So answer is equals to k by c under root v by under root a, which is option 1. Students, I hope you are understanding. So moving with the next question. Moving with the next question. The error in the measurement of the length of the simple pendulum is 0.2% and the error in the time period 4%. The maximum possible error in measurement of L by T square is 4.2%, 3.8%, 7.8%, 8.2%. We have the solution given delta L by L into 100 is equals to 0.2. Given delta L by L into 100 is equals to 0.2. So maximum percentage error L by T square delta L by L into 100. As I told you student, if the things will becomes in the multiplication or in the division but they have some power, so that power comes earlier. That delta T by T into 100. We just put this value and get the result 8.2%. I hope you understand. The next question which we have. While measuring acceleration due to gravity by simple pendulum, a student makes positive error of 1% in the length of the pendulum and negative error of 3% in the value of a time period. His percentage error is a measurement of a value of a G is 2%, 1%, 7%, 10%. So we have the solution like given delta L by L into 100, that's the percentage error, which is equals to 1, delta T by T into 100. So G is directly proportional to L by T square. Percentage error in the G is equals to delta L by L into 100 plus 2 times delta T by T into 100, which is a 1 plus 2 times of the 3. So 7%. According to this, third option is the right answer. Next question we have the measured mass of the volume of a body are 53.63 gram and 5.8 centimeter respectively with the possible error of 0.01 gram and 0.1 centimeter cube. The maximum percentage error in the density is about 0.2%, 2%, 5% and 10%. Now move with the solution part. This is a very easy question. So delta rho by rho into 100 is equals to delta m by m plus delta v by v times 100 for the percentage. We just put all these value over there and get the result this. I hope you understand. For more elaboration, student, like what you have to put, delta m 0.01 gram by 53.63 plus 0.1 divided by 5.8 into 100. You just have to solve this and you get the result 2%. Next question we have, the length and breadth of rectangular object are 25.2 centimeter and 16.8 centimeter respectively, and have been measured to accuracy of 0.1 centimeter. The relative error in the percentage error in the area of object are, we have these equations. Now moving to the solution part. Delta A by A is equals to delta L by L plus delta B by B. Percentage error we can calculate, which is comes the first option. I hope students you understand. Next question we have, the following observations were taken for determining the surface tension of water by capillary rise method. Diameter of the capillary D is equals to 1.25 10 to the power minus 2. Rise of water in capillary tube H is equals to 1.45 10 to the power minus 2 meter. G is equals to 9.80 meter per second square, and using the relation T is equals to RHG by 2 into 10 to the power 3 Newton per meter. The possible percentage error in the surface tension T is, we have an option 0.15%, 1.5%, 15%, 2.4%. So let's move with the solution part, students. T is equals to HR rho G by 2. Now for the percentage error, delta T by T percent is equals to delta H by H plus delta R by R plus delta G by G into 100. Now we just put all these value here and get the value 1.5%. I hope you understand, student. So the correct answer for this question is 2. Moving ahead. Next, 27 question. In an experiment, the value of two resistances were measured as R1 is equals to 5.0 plus minus 0.2 ohm and R2 is equals to 10.0 plus minus 0.1 ohm. Their combined resistance in a parallel is 4.4 plus minus 6%, 3.3 plus minus 7%, 5.5 plus minus 5%, and 3.3 plus minus 5%. So let's move with the solution part. Given two resistances are 5.0 plus minus 0.2 ohm, 10.0 plus minus 0.1 ohm. So R1 R2 is a given this, and delta R2 is a given this. We know the formula for resistance of a combination in a parallel, R1 R2 by R1 plus R2. From here we get the value of R, and maximum percentage error delta R by R into 100. From this formula we calculated, which comes in the case of error plus minus 7%. Now answer is 3.3 plus minus 7%, which is the option 2. I hope you understand, student. Next question which we have, if n is the rigidity modulus, R is the radius and n is the length, C is the moment of couple, then 2LC by pi n r to the power 4 has the dimensions of angle, mass, length, or a frequency. Let's take with the solution part. 2LC by pi eta r to the power 4. So here pi is a constant. This is a constant. And other like eta m1 l minus 1 and t minus 1. Here l r is a radius, which is the unit of a length. So which is the actually length. So L4 and here L for this and multiplied with this. C is here moment of a couple. So after solving we get the value of frequency. So the correct answer for this question is a 4. I hope student you are understanding the things. Next, the expression m e to the power 4 by 8 epsilon naught square h cube c has the dimension m is equals to mass, e electric charge, epsilon naught permittivity, h Planck constant and c velocity of light. N minus 1, t minus 1, m, and l. So student, I hope you remember that this is the actually Rydberg constant. Rydberg constant value. A constant which is a like Rydberg, which is denoted as a R. This is the value of that quantity, which is equals to 1 by lambda actually. So let us see with the solution. Okay, so they have a two different method. Like this is a method 1 by which we are saying what we did. We just put individual values like m. So here m, e means charge. So q like I is equals to q by t. So from here q is equals to it. Here 4 power, so I power 4, t power 4, like this. We have to put individual value. Or if we know this is a value of a Rydberg constant, which is equals to 1 by lambda, and lambda is actually wavelength. So again L. So we can directly like denote here L minus 1. So we have a two method. First method to put individual, and second method like if we know this is a Rydberg constant, so we in the place of a Rydberg constant we know this is a 1 by lambda. Okay, this complete value is gives 1 by lambda actually. If H is the Planck constant, m mass of the electron, e charge, so again H square epsilon naught pi me square has the unit. Now in this question we have to ask unit. Options we have Newton, joule, watt, meter. So solution, we just put all this value, and this value comes with this term which is equals to meter. So student, as I told you, the value of this pi me square by h square epsilon naught. This gives value actually 1 by lambda. So just opposite this gives lambda, and lambda is equals to meter. This is I have a like second method you can say, and first method you have to put all individuals dimensions. Next we can move ahead. If E is the charge, M is the mass, epsilon is the permittivity, C is the velocity, and G is the gravitational constant. So these has the dimensions of, these complete has the dimensions of. For this question students, moving to the solution part, we have a given options also. So the options are time, mass, length, and force. Solutions which we have, we just put individual values of the dimensions, and this gives the actually time equation. Next question which we have, dimensional formula for solar constant is this, second, third, and fourth. We have these options. Now move with the solution part. Solar constant sigma t to the power 4 r square by r square. So we put all these value and get the like unit mt minus 3, which is the option second. Next we have solar constant and Stephen constant have same dimensions in mass, length, time, all the above. So the correct answer for this question is solar constant is actually ml0 t minus 3. Stephen constant ml0 t minus 3 theta naught. So all of the above are the dimensions, are the part of the dimensions of a solar constant and Stephen constant. Next question we have, if m is the magnetic moment, mu is the magnetic permeability, and h is the density of a magnetizing field, then the dimensional formula for mu mh is ml2 t minus 2, ml2 t minus 2 I2, ml2 t minus 3, ml2 t minus 2 times I. Solution, mu is equals to ft square m1 m2. So we just put all the dimension formula here and get the value of m, which comes ml2 t minus 2. This is the final value of mu mh. I hope you understand, student. Moving ahead, if F is the force, mu permeability, H intensity of magnetic field, I electric current, then F by mu Hi has the dimensions of mass, length, time, energy. So we have a solution, F is equals to mlt minus 2 mu mlt minus 2 I minus 2 and H IL2 IL minus 1. So I is equals to I, again we just put all the dimensions and a little bit solution, get the result length. So the correct answer is the length. Next question we have, if density D, acceleration A and force F are taken as a basic quantity, then time period has a dimensions 1 by 6 in F, minus 1 by 6 in D, minus 2 by 3 in A, and all the above. So let's see the solution. T is directly proportional to the D to the power A to the power B, and F to the power C. Putting all these dimensions with their power, so M0 L0 T1 is equals to ML minus 3 A and LT minus 2 with B and ML T minus 2 with C. Okay. So comparing the power, so A plus C is equals to 0 minus 3A plus B plus C is equals to B, and not B here came, something will change. Wait, I have to put all these value. So M0 L0 T1, it comes M A plus C L minus 3A plus B, and with that plus C, and T minus 3A minus 2B minus 2C, this value. This minus 3A plus B is equals to 0. This is a not actually B, this is a 0, and this value, yes. So after solving, we get the value of a B plus C is equals to half, minus 3A minus half is equals to 0. After solution, we get the value of A minus 1 by 6, B minus 2 by 3, and C exactly 1 by 6. So the correct answer is a fold that all of you. Next, the viscosity eta of a gas is determined by its density D, molecular velocity C, and its mean free path L. And eta by dCl has a dimensional formula. MLT minus 2. Next, MLT minus 1, M0L0T0, ML0T minus 1. Solution which we have, eta is equals to ML minus 1 T minus 1, D is equals to ML minus 3, C is equals to LT minus 1. So eta by dCl is equals to M1 L minus 1 T minus 1, M1 L minus 3 L T minus 1 L. This will be after solving M0 L0 T0 comes. This is the third equation. 38 question says, the critical angular velocity omega of a cylinder inside another cylinder containing a liquid at which its turbulence occurs depends on viscosity eta, density D, and distance x between the wall of the cylinders. Then omega is proportional to eta by x square D, eta by D square x, eta squared by xt and xt by eta. So student solution which we have, omega is equals to t to the power minus 1 according to the dimensions eta m l t minus 1 d density ml minus 3 xl. So we just put all these value and comparing the mlt powers, got the result a is equals to 1, b is equals to minus 1 and c is equals to minus 2. I hope this is a little bit solution so you are enough capable to solve this particular part. So like final answer which we can get, this is the option 1. Moving ahead, if young modulus y, surface tension S and time t are fundamental quantities, then dimensional formula of a density is, now let's see the solution of this question. Surface tension symbol is S, so rho proportional to y to the power a, S b t c. So y is equals to ml minus 1 r minus 2, S is equals to mt minus 2, density ml minus 2. Putting all these value, again same thing we have to do, comparison the power of mlt. A plus b is equals to 1, a is equals to 3 we receive, and here after solving c is equals to 2, we just put this value of a and c in the any equation. We got the value of b which is a minus 2, and after a little bit solution we get the result like rho is equals to s minus 2 gamma 3 and t 2. So this is the final result which got by which we receive the answer 4th. Next question which we have, the length, breadth and thickness of a rectangular lamina are 1.024 meter, 0.56 meter and 0.0031 meter. The volume is a dash meter cube, 1.8 10 to the power minus 3, 1.80 10 to the power minus 3, 0.180 10 to the power minus 3 minus 4 and 0.00177. Most of the students are thinking like the first option and the second option are exactly same, but this is not. According to the significant digit, this is a different. Okay, so like there have a 3 significant digit and here have a 2 only. So length is a given, breadth is a given and height is a given in this form in the meters. Formula we know LBH, length, breadth, height. In the multiplication, we simply do multiplication part and like the value as we receive 1.78 and the power minus 3. So V is equals to, we receive 1.8 and to the power minus 3, because according to the round off, when we taking the round off of this number, so this 8 is greater than 5. So in the previous digit, we just raised 1. According to this, the first option is the right option. I hope you understand, student. Moving ahead with the next question. The diameter of a cylinder is 0.55 centimeter. Its length is 1.35 centimeter. Its volume is a dash centimeter cube. 0.3240, 0.32, 0.324, 3.2. Student solution which we have, D is equals to 0.55 centimeter, R is equals to 0.275 centimeter. Because we know diameter by 2 gives a value of a radius. L 1.35 centimeter. So volume, area into length. So area pi r square and into length. Pi 3.14 r square, this is square, and L we given. So from here little bit calculation need and we got the value of a V. Rounded the answer to the minimum significant as in the problem is given. So 0.32 centimeter cube is the right answer. For that, second option is the correct answer. Moving ahead with the next question. The diameter of a wire as measured by a screw gauge was found to be 1.002 centimeter, 1.004 centimeter and 1.006 centimeter. The absolute error in the third reading is 0.002 centimeter, 0.004 centimeter, 1.002 centimeter, 0. The solution we have delta x3 is equals to x3 minus x min. Given that x1 is equals to 1.002 centimeter, x2 is equals to 1.004 centimeter. So x3 1.006 centimeter. So x mean is equals to x1 plus x2 plus x3 by 3. Putting all these values here. After solving, we receive 1.004 delta x3 minus x mean. So we put all these value, get the result 0.002 centimeter, which is option 1. Next question. Dimensional formula for a physical quantity x is m minus 1 L3 T2. The error is in measuring the quantities m, l and t respectively are 2%, 3% and 4%. The maximum percentage error that occurs in measuring the quantity x is 19%, 9%, 17%, 21%. Solution. The dimension formula for x is equals to m minus 1 L3 T2. After putting all these value, delta m by m into 100 is equals to 2%. Delta l by l into 100 is equals to 3%. And delta t by t into 100 is equals to 4%. So we just put all these value in the error percentage formulas and receive this value 19%. Hence the correct answer for this question is a 1. Next question. The heat generated in a circuit is dependent on the resistance, current and time of the flow of electric current. If the percentage error is measured in the above physical quantities are 1%, 2% and 1%, the maximum error is measuring is the heat is. We have an option 2%, 3%, 6% and 1%. Moving with the solution part, student, we know that the value of R is ml to t minus 3, I minus 2, q ml to t minus 2. So in the percentage, delta R by R into 100 is equals to 1, delta I by I into 100, 2%, delta t by t into 100, again 1%. So what we did, we just put the formula in the dimensions, comparison and get the value of A, B and C. So from here, what we receive, like the formula which we receive, Q is proportional to the R I square T. So I, if they have some quantity, if they have some power, so what we are writing in the multiplication of this system, like here, this will be in the cube. T is equals to, as we saw here, C comes with the Q. Yes, so we just put it here and get the result. This is actually not this, because here this is a T. So this comes like delta T by T into 100. And this value as the comes like T1. So this value is a given 1%. That's why I'm confused over there. So 1% is for this and 2 for this. 2 into 2. Okay. And again 1% for this. So overall we received 6%. I hope you get the like proper answer, student. So according to that, the third option is the right answer. Next, the percentage error in A, B and C are 1%, 3%, 2% respectively. The percentage error in X is equals to AB square by C cube can be plus minus 13%, plus minus 7%, plus minus 4%, plus minus 1%. Student, the question is easy because what we have to calculate simply the x error. Solution, the x error again, delta x by x into 100 is equals to delta a by a into 100. Again, they have some power. There is a no need if you are writing like this, c power minus 3. So this is a neither form for written this. This is not the correct way. If you have equation this, you easily write up the 3 is in plus. Okay, as I written over there, like plus 3. There's a no need to write if you just put it like this, ab square c minus 3. So like as the power you are writing plus 2 for this. So but this is a actually division form, not we are just putting the errors. Okay, our error can't be negative. If you have some did some fault in a one day and second day you have did some fault, so that fault will be added, not subtracted. Like this, you like one day you 100 rupees, like you have a actually like fall 100 rupees and next day you have fallen to 200 rupees. So if your mother or your father will be know about these things, so they will be slap you. Okay, I'm just simply giving the like examples, students. So like that, errors are always added, not subtracted anywhere. Okay, so we just put all these value over there and get the value 1% for this. Okay, this is the right answer. So 13% is the correct answer, which is the option 1. Next, the density of a cube can be measured by measuring its mass and length of its side. The maximum error in the measurement of mass and length are 3% and 2%. The maximum error in measurement of a density of the cube is 9%, 19%, 10%, and 90%. Move with the solution part, student. Formula we know that D is equals to m by v. V is what? Length cube. So we did like this. Again, unit of mass. L cube in the downside. There is a no issue. Take the plus 3 and divide by L. Put all these value in the given format as the percentage is a given. Put all these value over here and get the 9%, which is option 1. Next, the error is the measurement of a length of a simple pendulum is 0.1% and the error in the time period is 3%. The maximum possible error in the measurement of L by T square is 6.1%, 6.0%, 3.1%, 6.2%. Now put all these value in the percentage form. So maximum possible error in the measurement of LT square, L by T square is found as a 6.1%. According to this, the correct option is second. First, question number 48, the resistance of a metal is given by V is equals to IR. The voltage in the resistance is V is equals to 8 plus minus 0.5 volt and the current in the resistance is I is equals to 2 plus minus 0.2 ampere. The value of a resistance with its percentage error is, we have an options are these. Let's move with the solution part. V is equals to 8 volt as a given, I is equals to 2 ampere. Simply we just applied Ohm's law for the error also. Put all these value over there and get the result for error plus minus 16. Okay, so the value of percentage is R by R. So this will be gives 4% plus minus 16.25. Option 1 is the correct answer. 49 question we have, if the R is the resistance, C is the capacitance, and then the dimensional formula for RC is LT minus 1, T minus 1, M, LT minus 2, and T. So R resistance ML2, T minus 3, A minus 2, and C capacitance M minus 1, L minus 2, T4, A2. According to that, the correct answer is T. I'm little bit solving over there like how this will become. So M, this will becomes like M plus 1 minus 1, L2 minus 2, and T minus 3 plus 4, and A minus 2 plus 2. So as you can see over there, M0, L0, T1 and A0 comes in the nature. So finally we can write as a, like this will be what? Actually, T1. So T. Last question we have, if the h is the Planck constant and lambda is the wavelength, so h by lambda has a dimension energy, momentum, moment of inertia, and frequency. Solution we have, the unit of h is, or dimension of h is ml2 t minus 1. Lambda L, so substituting all these value h by lambda, we got the result for the momentum. Okay. So students, this is all much for today's class. I hope you understand and learn many things a lot. Keep watching these videos of a series because these are so much helpful. And yes, keep with us. Thank you so much for watching this video.